Hey everybody, this is Larry. This is me doing a bonus question for the day, an extra question. Hit the like button, hit the subscribe button, join me on Discord, especially if you'd like to see more of this. It's me trying to do a random one that I haven't done before, so I do it to do. But some of these are, as you can see, premium, so I have to keep clicking until I see one. But yeah, let me know what you think because I don't know, I might not do it anymore if people don't, if it's not something people want to see. But either way, I like to do a few more problems so for today. It's just additional good practice. Anyway, today's problem is 564. Find the closest palindrome. I haven't solved this before because okay. Given the n is integer, return the closest integer not including itself, which is a palindrome. If this is a tie, return the smaller one. So it could be bigger or the smaller one. So that's why. Okay. Which is not itself. That's a little bit awkward. Okay, so this is that it fits in the long, that's fine. Okay, let's see, right? Well, I mean, okay, let's, I guess first I'm gonna, this is one of those problems that I feel like will be, this is one of those problems that I feel like it will be like what am I looking for? The word was constructive algorithm, right? And what I mean by a constructive algorithm is that you have a strategy, try to figure it out, and then maybe find some brute forcey way and kind of put it together. For me, or like some kind of strategy, right? Maybe sometimes it's greedy, and sometimes you just do it to figure out how to like if you're able to brute force in a smarter way, and. And the question that one idea that I have, and I don't know if this is true, but let's just say I have like a big number, like this is my number, say, then I'm thinking that, the answer has to be, I guess my question is, does the answer have to be, like, do we take the prefix one at a time? Meaning, okay, let's just say this is the prefix, then we would try to convert it to 3, 4, 5, 3, 2, 1, right? It's still not a possible solution. Yeah, we could do. Is that really it? I mean, there's obviously the other way of trying to do the prefix, but I don't know if that makes sense. Like if you convert it to 9, 8, 7, 6. 5, 6, 7, 8, 9 or something. But you can even, if you're consistent about it, you could just generate this and it'll be the same thing. But the idea behind the minimum difference is that you only want to do the suffix, I think. Right? And then the question is, let's just say we do use this algorithm. Then the idea is, is there a way that I can do better? I don't think that you can, well, okay. So in this case, this is worse, right? Clearly. But let's say you have another number, right? Let's say your number is 987654321. I guess it's still the same way, right? I was going to say that you can try to choose a smaller number, right? But of course, in this case, your difference is like 800,000, so then it won't really make sense. And so even though you get a bigger number, you still want something like this, right? Okay. So the still question though is, can you do better? Like, and they may be a little bit tricky, right? For example, maybe we can do something like 1, 2, 3, 5, 5, 5, 3, 2, 1, right? What is the difference between here? I mean, this one is going to be a bigger number because bigger difference. Just because this number changed and that's a more significant digit, right? Is this good enough to YOLO? I think one digit is the only case where you do this funky thing. So maybe we can do something even just lazy. If length of n is equal to 1, then we return int of n minus 1 and then string of this or something. And this length is 0. Then it has to be okay, fine. int of n is, oh, it has to be 1. Okay, so we don't have to worry about it. I was just looking at the constraints. Oops. So okay, and then if not, do we always just return it? Okay, this is what I'm gonna do. I'll show you. I'm gonna try to do this, and then what I am gonna do is what I am gonna do, there may be some really tricky ones, right? I think the tricky thing is what happens if it's a palindrome. I think that's the answer that didn't answer. For example, what if we are already given this number, right? Then what's the next biggest number? I guess in this case we would have to change this one, because then now we change this one, right? So I think that's maybe the idea. And then also this is a even, oh sorry, this is an odd digit thing, so we have to try some even digit numbers. So let's say we only go up to 8, then we go 1 2 3 4 4 3 2 1, and then to get the next one we get choose this one number. So okay, so I think the idea here is now take the first half, okay, so maybe that's why, maybe I don't even need this to, oh actually did I mess up? Well no, I mean I not yet anyway, because I said that for here I can go 4 4, but and then we go to 5 5, but we would also maybe test both 3, or in this case actually the 5 is in the middle, so I lied. What we could have done is just change this to 6, or change it to 4 in this case. Yeah, maybe that is the answer, is that we take half, so left is equal to n what's it, length of n over 2, right? I think that rounds down, so let's try some examples really quick. I'm always very bad at using this notation, just something I'm not used to, I suppose, coming from C++ or something. So 1 2 1, oh I guess the 1, okay, so we are definitely missing the odd number. The 1 got skipped earlier. Maybe we don't need this actually for now. So yeah, okay, so that means that we want this. I think that's probably what we want. Okay, right, though maybe just to kind of minimize the number of possible mistakes and generalization, let's actually just change this to, if this is even, then we have this thing, I mean this form is right, and then we have this thing, right? Just reworded this, so this is the right side, and then we have try, this is a temp maybe, is equal to left plus right, and these strings are at most like 9 characters, so we'll be okay. And then here we just have to check if a temp is equal to n, then we have to go do another thing, otherwise we return the temp, because that's good. Or maybe we just do this, and then if a temp is equal to n, then what do? Well, we take, so left is equal to int of left, we want to choose +1 or -1. I guess +1 and -1 has the exact same thing. So, and in that case, we'll choose minus, unless it is unless it's something weird, right? Because for example, let's say we have 1 0 0 0, and then this is the right half. If we try to subtract 1, then we have 9 9 9. Well, I guess that's no, because then now it would have 2 fewer digits, which is great for getting a smaller number, but then now the difference is so big versus just 1 0 0 1 1 0 0 1. I mean that's good too. Okay, so I guess we just try both. I think that's the idea. I maybe could prove it, but I think this is just safer, right? So okay, so let's just try let's just say x is equal to int of left -1. Let's just say new left, maybe. Yeah, and then new right is equal to this -1, and then you just have new number is equal to int of n left plus n right, right? Yeah, okay. And this is maybe we'll do negative. Maybe that's what it means. And then now we have +1 of this. So we do the same thing. This is, I probably should make this cleaner, but I'm just trying to, this is more of a proof of concept, and it's okay when you don't have to write clean code the first time. I mean, you strive, if you know what you're planning out, you should do. Of course, in software engineering, in regular software engineering, you generally try to think about a problem a lot more before coding. But for me, for this particular problem, it's more about like the exploration, right? So the code maybe is a little bit ugly, but you can improve on it later. And then anyway, so if okay, I need to do a little bit better about that. So let's just say current is equal to int of n. So if absolute right, and we know that this number will be smaller, or this number will be smaller. So anyway, so this number is greater than this number, then we return pnum, right? Else we return the nnum. I think this is mostly right, but there is some abstraction that we can do here, but we'll see. So now let's say we have odd number of digits. I think we do the same, to be honest. So maybe I don't. Oh, I think the difference is this part, the reflection part. Yeah. Okay. Maybe for now we just copy and paste. This is very yucky though. Do not advocate this, but nonetheless. How do I do this? Let's just say we skip the last number and then we flip it. I always don't know the exact notation. That's why this is a little bit awkward. But nonetheless, and we're only dealing with 9, 10 digits, so that's why we can get away with being as lazy as possible with these things. This looks good for these inputs, but that doesn't mean enough if you ask me. And then I'm just like banging on the keyboard, of course. All right, let's give it some spin. Okay, so we definitely have a wrong answer. That's not great, but expected is this. How do I try this? So I turn it to 1000 on the left side, right? Maybe I do this wrong. I mean, I know this is pseudo cheating, but we could have checked this. One thing that I was going to do is actually write a brute force method, and I was going to maybe highlight it, but now we can just debug this part for now. But let's see. Okay, wow, this is the only case where this came up, which is actually very awkward. Do I only have odd number digits by accident? Yeah, well, or at least ones that did not. Oh, I guess this part is the case. Okay, but this is why I put this in there, right? So we did try both these scenarios. Did I have a sign error? Why do I return this number? If the absolute value of this is greater than this, and it is, right? This is 2000. This is 2. Huh? Did I mess something up? Dong dong dong. Did I add an extra C? Oh, that is the tricky part. Okay, so because this is now 1000, we don't try to. Okay, so we have to be a little bit careful. That's fine. Because if you have even number of digits, if you create a new digit, that actually creates 2 new digits. By eyeball test, I actually didn't line them up, but now that I see it, that makes sense. Okay, I mean that's fine. What we want to do then is just maybe do a third one, I suppose, where let's see, okay. Well, in this case, if we subtracting a digit, I think is fine, right? Because we know that the +1 will fix it, right? Because if we subtract an extra digit, that'll give us a number that's too big, but also not so good, right? Because if I don't know that I put this in an example in the thing, now that I think about it, maybe I can do it. I was trying to be lazy, but I think I had this here, but I didn't do it for even digits. So even digits is the pain in this one, because in this case what I expect is a lot of 9s, but it might not be because it thinks that it only has 6 digits, so it really eliminated it. So yeah, okay, so okay, this is expected given my input. So yeah, so that's good that we caught it. And this only happens with even, does it only happen with even digits? Let's see, right? If we have, yeah, I guess so, because with odd number of digits, if you lose a digit, no, well, trying to think. Well, I mean, I think the thing is that now we just try all 4 things, right? Yeah. Okay, so that means that in that case, there's no difference between these two. We could rewrite this. It's fine. We have to, because now we can just do these things in a good way. Okay, so that means that well, okay, then we can do something like, we can rewrite this part real quick. Just put it here for a second, because now everything is the same except for the top part. And then now we want to just try all 4 possibilities, really. And I'm a little bit lazy, so I'm just going to do something like possible is equal to and then here we do let's just say num absolute current minus num, actually the other way around, so that we could sort by this in case you haven't seen it yet. And then yeah, and then now I mean, I'm still going to do it this way, but I'm going to make it a little bit more copy and paste friendly. Maybe in this case we can even do something like for dx in -1 1, we do this thing, and then now we can just do plus dx, right? And then here we can also reuse this anyway, the same idea, but now this is the only different thing, but that's fine. Maybe I'm okay with just leaving it like this for now, and then back to putting this, and then now we sort real quick. or you could just get the minimum element, I guess. But anyway, you get the possible of the first element and then 1, and then we want the string version of this, and that's maybe it. We'll see. Oh, huh. I thought I tried all the possibilities, but maybe I missed one. Oh, I still have wrong one. I thought I tried to do that. So now we have, maybe I didn't think it through. I mean, I did make the code tighter, and that's what I mean by sometimes, you know, once you finally finish exploring, the code will be cleaner. What I need to do is going from even number of digits to odd number of digits. That's the part that I didn't remember to fix it, because here it just it handles the other one where you have odd number of digits, and then now you want to, you know, there's like some mosquitoes that I'm trying to kill. Okay, you got it's not mosquitoes, it's like a mini fly thing, maybe somewhere again. But yeah, we have to get it to odd digits, and because the way this. So the other thing that I was attempting was 999 or something like this, but 6 digits. So let's print it out real quick. I'm just curious. Okay, yeah. So it was it one, the palindrome is 1000, so it tries to do 1011. That's fine. This was fine as well. Huh, did I miss a digit here? Maybe that's why. Because then it goes 999, but it's not enough digits. That's the thing that I initially said, and that's fine. How do we want to do it is that, you know, if we lost a digit, we add a 9. Is that weird? Okay, maybe that makes sense. Okay, let's give it a spin then. Would it be this one or the other one? So we have 4 digits, we lost a digit, and we want it to be, so if we have 4 digits and we want to get it to 7 instead of 6, right? In that case, it would just be this, because it'll be even. Yeah, and then it'll be this plus 9, right? Because you lost a digit. Let's see if that works. I don't know if this is a good enough hack, to be honest. Are we still wrong on the same answer? No, wait, what are we wrong on then? Okay, so this is an early one. We just skipped over it. Did I not do this one? I thought we did this. So for odd number, we have 1000 thing, and then we cut it to 999. Here we only do this part because we want to do it, but then now we want to get rid of one of the digits. No, wait, why is that one? Oh no, of 999, but then the way that we did the reflection, it would only be that, but I thought that this would fix that. Huh. Let's see. All right, let me put it in again. Which one was that one? I guess next to 523, whatever. So it's this input. And I guess, oh, I see. No, this is right. I think we generate the right thing. We just didn't minimize the, doesn't it? Dong, dong, dong. All right, let's just put this in the back to see what it's doing. I think maybe it's still right, but maybe I just didn't like sort it correctly or something. But that should be okay, maybe. Let's see. Right. Okay, so here we have, 1 million. Clearly we're, oh, I see. We're just returning early. That's why. Oh, I see. Because we're returning early, we're using our original strategy. This actually throws us because we don't add it, consider it to the other thing. Okay, I guess what we do here then is just add it to one of the possibilities and we don't early terminate. That's basically it. Yeah. Possible dot append to absolute of attempt minus oops, the other way. And I think that should be good. Because then now it should sort by, because I didn't think that sorting okay, we have to make sure that int, because I didn't think that was a sorting issue, even though it didn't make sense, because this would have one, the number 1, and then this would, you know, this would be the actual number, which is if it's bigger than it wouldn't type it correctly. But okay, what are we doing wrong here still? What am I returning? Oh wow, we're wrong in a lot of places. But why? Oh, we have to get rid of the zeros. I guess that's the... Okay, I guess that we had an if statement here, but then I just took it out for some reason. With a temp is equal or not equal to current, then we do this thing. That's what I meant to do, but I think I was just so focused on making sure that this is right that I forgot about it. Oops. Like someone like that making a silly mistake there, but it's an annoying problem. But that's what I meant by I had a feeling that this is a thing where you this is a thing where you try a lot of combinations and one of them will have to be good using a combination of heuristics. Oh no, did I mess this up? Oh, okay, I guess the 2-digit case is very weird. This is a very easy to mess up one, even as we spent a long time. I was focused on these other weird cases that I didn't consider the cases of one number and stuff like that. I should have added more though. I just kind of got distracted about it. Let's see. Okay, so yeah, 2 is clearly wrong. Maybe I shouldn't even look, but all right, let's think about how do I want to do it. I mean, I don't think these are special cases. I don't know why I can move this. I can move this left and right, but I can't move this up or down just to look at more test cases, which is very sad. But okay, 11. What is 11 doing? All right, let's put it back out again. That's also why I forgot about this part, because that's why I wasn't putting out as much as I thought. Okay. So we were trying out for 11. I guess I could just print out 11 as well. Well, the answer is 9. I think I thought one of these would generate 9 for 11, because then the left would be 1, minus 1 would be 0. I think 9 is just a possible answer in general, so maybe we should just try 9 always, because if it's 2 digits it could really be messy. Yeah, it's kind of like this one, I suppose, in that way. But 9 and I guess not 11. 10. Okay, let's just always add 9 and see if that fixes it. Oops. Okay, so there's still a wrong answer. And that is on, oh, well, if, I am such a dum-dum. If current is not, you go to 9, I suppose. Though we should just filter out the zeros, but alright, let's give it a spin. Hopefully this is right. Maybe I should have tried 3 digits, but yeah, okay. I thought that this gets figured out. Isn't that one of the things that we test? I don't get it. Don't we take half and then try to... Oh, huh. I guess we missed that one then, don't we? Also, isn't this... Oh no, this is... It's right, but we just don't... Because it tries to do 99 for odd numbers, and it tried to do 100, but then it tries to do... so it... wow, this is sloppy but hard in general. But yeah, now it goes to 99, tries to do 100, which it tries to do this, and then also, you know, this, but it never tries to do this. Yeah, so I don't think, I mean, this is probably more than this case. They're just other odd digits where this is wrong. Yikes. What do you think? I think in that case, I wonder if it's like worth doing like an all nines, like always check for all nines, and always check for 10001 or whatever it is. I think these are the only weird edge cases as well. So maybe I should do that. What do you think? I know you can't answer me, or at least I can't hear you. So yeah, I think that's the way I'm going to do it. I think that those are all the edge cases anyway. And we could have written things in a way that would address it. But is that good enough? Because the problem isn't getting a palindrome, it's about getting the closest one. And yeah, this one is a little bit awkward with respect to everything is incremented. Because you can even think about 1,000, and 1,000, I guess 1,000 would fix, but not 999. All right, let's give it a try. I don't know if I, you know, yeah, I don't know if I, you know, whatever, but I just say 20. It doesn't matter because I'm a little bit lazy. If now, and then yeah, something like this, right? That's for one way, and then we want to do the other one where you know, maybe someone like times or plus times x, right, plus 1, right, something like that. And we could even just make it equal to, it's fine, but all right, let's give it a spin. Let's give it a, oh, we already did put it in, okay. Let's give it a quick submit. I'm really worried about just like carries, right? But this is a double carry. I think that's the issue. And as you can see, we finally got accepted. We do a lot of stuff, but this is mostly right, I suppose. Yeah. What is the complexity? Well, this is, I want to say constant-ish, but maybe O of x, where x is the number of bits, which is log of n, the number of digits. So in theory, this is linear-ish. It's not very pretty linear for sure, but it's linear-ish. Though maybe you could say this is quadratic, maybe, because the 20 is maxed by the number of digits of n. So this is O of n, and this is also O of n to generate. So yeah, maybe this is n squared. But either way, yeah, let me know what you think. This is a very hard problem. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Yeah, this was tough.